Hello, my name's Mark and I am G-Code Tutor, and today we're going to be looking at creating a back chamfer in a bore. Okay, so we have some options when it comes to creating these back chamfers. So what I'm talking about is as we create a bore, at the very end of that bore, at the back of the bore, we can create a chamfer. That way it saves us doing a second op on this part. So as long as we can part off nice and cleanly and flat, it saves us popping this back up in the chuck just to do that chamfer. Okay, so here's how we can do it with G-code. So we're going to start off by our standard introduction line that gives us an operator's note to let the operator know what this section is about, and also an N number. Now they don't tend to be used much anymore, but I use my search functions so I can search this block of code with ease just by using the down arrow on the FANUC controls. The next line is our safety line. I've spoke about this so much in the past, so if you want to know more about safety lines, check out one of my previous videos with Practical Machinist. Okay, so the next line is our tool call. We're using tool 5, offset 5, or data table 5, and MO6 creates our tool change, brings the tool into the center line of the machine. And then we're going to set our spindle speed. So I'm setting a spindle speed here of 2,200 RPM, and MO3 turns the chuck on. Now, if you find your chuck is spinning the opposite way, quite often with turning, we mount our tools upside down. You might need MO4 here. Okay, so our first GO move. So G00 is our rapid travel move. We often see it shortened to G0, but as I'm teaching G-code, I'm doing it the proper way, and that's G00. The reason we used to shorten it is because memory in machines never used to be that great, so every bit counts. So if we can save one digit off of a value, and then that can save a lot of space in our program. Of course, these days we have almost unlimited storage, so it's not a problem. So I'm moving down to X and Z there, X and 16, that's the diameter of the bore. So we're going in for a finishing cut of our bore here, and Z gives us some clearance away from the front of the part. Now I always leave a bit of clearance here, that way we can make sure if any collisions was to happen, we can see it well in advance. And that's also why I often do this line in two moves. So I'm bringing down in X and Z first to a nice safe clearance, and then finally a second line where I bring that Z right in close to the part. So that first line gives me the chance to eyeball that tool to see if, yeah, it's about 5mm away from the front of that part before I run the second line and the tool gets real close. So it's just another safety check to make sure I've set the tool correctly. This next line, we're doing point-to-point GO1 boring. So GO1, our feed rate command, we're going down to Z18. See the depth of that chamfer there, the part is 20mm long, that chamfer is 2mm by 45. So I'm stopping at the front of that chamfer there, and we're feeding in, doing a nice finish across that bore surface. All ready for the next line when we cut that taper, when we cut that chamfer. So I'm moving to X20, Z20 here. So that would create that 45-degree chamfer. Now, there is an issue with doing it this way. So if we part off to size and that chamfer is to size, there's going to be a burr. It's going to roll that material over on the edge of that chamfer. So we're still going to need to do a bit of work on this part afterwards to get rid of that burr, whether it's by handy burring or maybe we might need to use a machine depending on the material we are using. So how do we get around that? Well, instead of coming down to the exact endpoint of that chamfer, we can come a little bit past it, such as this. So instead of coming down to Z20, I'm coming down to Z minus 21. So that brings us 1mm past the end of the chamfer in Z. But because we are looking at this as a 45-degree angle and we're only calculating the 45 on one side of the part, the X has to be double movement, and that's because usually we work in diameters on a lathe, but in this case we have to think in radiuses. So whatever we move the Z when creating a 45-degree angle, we have to double it for the X. So that's why the finishing point X there is 22 and not 21. Okay, so by creating this, we're continuing our 45-degree chamfer past the endpoint, and we're going to keep going for an extra millimeter. This way, when we part it off, we're passing off into that angle and not onto where the angle ends. So once we're down to just past our depth on that chamfer, now I can bring the tool a little bit past there again. So I'm moving another 2mm, just cutting a little groove on the inside there, just past the chamfer. That way we know we've got some clean material to pass off to. And if our passing off tool is slightly angled, then we're going to have a much cleaner cut. So the other thing we need to watch here is the tool. Quite often, if you do this procedure and you find that the chamfer is not creating as good as you wish, it's probably rubbing on the back side of your tool. So make sure you have 45-degree clearance on the back of your tool when you are doing this. Okay, so with that done, we can now rapid to a safe distance. I'm bringing the tool up in X, so now we're not near any material, and that gives us the ability to bring it out in Z, 5mm clearance. Okay, so with the tool clear, we can now send it back to its tool change position or its home position, and there's many ways we can do this, but I like to use G53. And we're also turning off the coolant there at the end with MO9. MO5 turns the spindle off, MO1 is our optional stop, so we can stop the machine and make sure everything is fine before we continue through to the next tool. So that's how I write a program for the back chamfer. Now if you enjoy learning about G-code, machine shop techniques, CNC programming, computer-aided design, and all the other skills that you need in a machine shop, pop over to my website at gcodetutor.com, where I have a range of paid and free articles and courses to teach you all about this awesome trade.